All right, we've got our last bit of information on waves about sound and light and how they work in different areas. So the first part was to watch this quick video. Should have been a clip from the Big Bang Theory about the Doppler effect. So we'll use that a little bit later as we get into wave information because we're going to talk about the Doppler effect right here. So with the Doppler effect, what you see is that there's a change in the sound of an object as it's moving. Right, as an object comes to you, the waves change frequency, or it appears to, because they're compressing. And as it moves away from you, they're spreading out, and you get a lower frequency. So what you get is that noise that Sheldon was making, where you get an increase in pitch and a decrease as an object moves towards you or away from you. So as we look down here, the ambulance is coming. We get an increase in pitch towards this individual, and a decrease away from this individual, and you see that with these rings here. So with that, pitch is determined by frequency. So the pitch of a sound, how high or low it is directly related to the frequency at which that sound makes contact with your eardrum. So higher pitch sound means higher frequency. So therefore, when we get changes in frequency because of movement, we get a change in what we hear. So again, feel free to pause if you need to. So this is exactly why we see the Doppler effect, where the frequency appears to change as the source or the observer moves, as you or an object that's making sound moves. And that impacts how we hear the sound waves. So as wavelength decreases or frequency increases, the pitch increases. As wavelength increases or as frequency decreases, the pitch goes down. So how does his costume show the Big Bang, from the Big Bang Theory, show the Doppler effect? Well, you'll notice that the stripes get narrower the closer it is to the source and wider as it goes away. So as you come in from one side, the waves are increasing in frequency, and as you move away, they're decreasing in frequency. And then answer question 2 just as a little reflection question here on your own. So last is changes in waves. So we have reflection, diffraction, and refraction here. So reflection is bouncing back of a wave when it hits a surface and does not go through it. And they reflect at a free boundary. And at a fixed boundary, they turn upside down. So you'll see here there's a fixed boundary. So the wave is coming in, hits it, and then it goes back the opposite direction. Here we have a free boundary, hits, and goes back. Okay. Most of the important thing, reflection, hitting, and bouncing back. So diffraction is a change in the direction of a wave when it hits an edge. So, and refraction is the bending as it passes between different mediums, basically. So you imagine what you see, when you're throwing a spear at a fish that's in the water, the fish actually isn't in the exact location you think it is because of refraction. Okay. So we got diffraction, which is splitting. We got reflection, which is bouncing, and we got refraction, which is bending. Bouncing, bending, and splitting. Last topic we'll talk about is interference. This is where two or more waves combine that results in a new wave. So crests are added together in this place, and crests and troughs are subtracted. So if my first waves and second waves, you see how their crests overlap, they add together. First wave, second wave, see how they're the opposite. They add together, but one of them is considered negative. So if that's positive, that's negative, you get a bigger negative, overall negative. And in this case, you see how they perfectly overlap? Well, they just balance out completely. And that's called the the principle of superposition. So constructive interference occurs when larger amplitude, that's this situation here, amplitude's larger than the originals. It's like adding crest to crest, trough to trough. Increases amplitude. And destructive interference is when you get a smaller one. So think crest to trough here, crest to trough here. Remember, I'm assuming you're pausing at these places. that decreases the overall amplitude. And it's possible, as in this third case, for them to completely cancel each other out. So we use interference to create displays of color. We create interference of sound to produce beats or other music. And that's, like the principle of interference, generally speaking, is why we get what we get with music and TVs and things of that nature. So here's another video on interference, and I believe that should be it. So now you can move on to your homework problems as well, which are basically based off of this information, and we'll go over that tomorrow. Thanks.